I'm fine, I'm fine.
Okay. So tired or something?
No, 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 I'm fine, I'm fine.
So how things are going with studies? All fine?
Going good. Half yearly is starting uh like from December 14th.
Okay, okay, okay. Okay, so shall we continue with our integration to get more
Yes,
about facing them?
yes, uncle.
Okay. Okay, so I mean it's not only for the integration. In general, when we are want to do something, then if we know everything about that in and around, then we know when we take any step to even to look at it or to analyze it or to do something like mathematics or physics or whatever it is, it will be better. So that is why I keep explaining whenever we do something, ask the question to a level that we have in and out about everything what is going on. So most of the time in mathematics and physics kind of subjects, the knowledge would be we would have faced the forward thing and we may be looking as an answer as a reverse thing. Do you catch that?
Yes, uncle.
Okay, so that is also sometime lot of things may be hidden and maybe not known to the teacher, not known to the people who wrote the textbook and also the videos, whatever available on the internet and everything. Because we can't expect the people preparing them have a good knowledge about that. They may have it, but not to the level of exactly what it is to a point that we can understand. Do you get that? So we need to look for that. So particularly in mathematics, always there is something called anything forward process, there is a reverse process. So for example, I just give you 2 plus 3, you know how to find the answer. What is the answer for this?
Fine.
5. Okay, good. So that means there is a forward mathematical operation of addition between two operands in the name of 2 and 3 as they both belong to the family of ones because the both the 2 and 3 they on the same number line with a gap of 1 with each step, right? From 0 they can go plus 1 and plus 1, then we reached the this point is our 2, right?
Yes,
Then the 3 also belong to the same family. So 1, from there another 3. So another plus 1, another plus 1 and another plus 1. So we go to, so this we call from this as the temporary reference 0. We have a 3 here from here. We get that. So there is a plus 3 here up to here. And there is a from this is the original reference 0 and from there we have our plus 2. Then put together we can say that actually it went all the way to 5. You're okay with that?
yes,
That is
yes,
we write it as a, so even with a graphical representation we should know. Similarly, if you want to get back a reverse operation, that means 5 minus 2, that means once you are in the 5, then you have to go. So the 5 is achieved by going from the 0 reference all the way 5 was achieved like this. Then the minus 2, this minus is the opposite direction. So always we say that this is our positive direction and this side is our negative direction. So we have to turn left, turn it, and then go 2 steps in that direction. Is that okay? That we call that as a
yes,
minus 1. Then we would have reached some value. This value we know that it is still on the right side of our 0, which is our positive 3. So that makes our answer as a 3. Same understanding should go for 5 minus 3 equal to 2. Do you get that?
yes,
You see, in the way I explain and make you to understand also in this way, because that will give us the complete idea what is going on. In some other way, if you want to handle these kind of things, operations and the quantities, we will handle it very carefully. Is that okay?
yes, uncle.
So now take an example of 1 over 2 plus 3 over 5. They don't belong to the same family. Do you get that?
Yeah,
The previous case, let me put a previous case, it was a problem of the 2 plus 3, as we know that 2 is also a family of ones and 3 is also family of 1s. Because the 1 is hiding, we don't normally write it. So that makes the problem much straightforward and simple. But in this case, it is a 1 amount of half family and 3 amount of 1/5 family. Do you see that?
Yes, sir.
You're okay?
Yes, yes, sir.
Okay, so that is the reason we have a procedure to go about it. The procedure is the main thing we need to understand. Why we go for least common multiple? We are trying to bring them as the same family. Then on the number line, we know both of them in the forward direction, and we can go in steps to reach the from 0 to half, and then we can go further in the same common family to the another 3/5 of that amount in the common family. That is the reason we start thinking, okay, take the denominators and write all the possible factors for them. So in this case, the multiplication factors for the 2 and 5 are 1 and 2 for the 2, 1 and 5 for the. So anything
Right.
common, we write only one of them for the LCM. Is that okay?
Yes.
And then these 2 separately participate on its own, and then the 5 participate separately on this own. So eventually we say that 10 is the
10 is
LCM
the
for
LCM.
least common multiple for between 2 and 5. Is it okay? So
Yes,
that
sir.
helps us get the job done. So we have 1/2 plus 3/5 as the starting thing, but we know that after finding the least common multiple, we want to convert the family to become the least common multiple as the denominator. So to reach that, the 2 is lacking a factor of 5, and we cannot do that extra thing mathematically only on the denominator side. To balance that, we do it on the numerator also to keep the value constant. Similarly, 5 is lacking a factor of 2. So 3 has to be multiplied by 2. So eventually this comes to 11/10. You're okay with that?
Yes.
Okay. So any questions so far?
No.
Okay. Now, nobody teaches us or even made the students or learners to think about like the 2 and 3 added gave a 5, we learned a subtraction like that. When we made a addition of fractional numbers and we have a procedure of bringing them to a common family and we did get the job done. Also, we learned a little bit about the 11/10 also. Whenever the numerator is greater than the denominator, then we call that as a, because of this, we call that as a improper fraction. Is it okay?
Yes, sir.
Improper fraction. So because of that, what is improper fraction is in that quantity, there is a one full whole amount of denominator is hiding here. So if you write that as a 10 plus 1 divided by 10, which is absolutely correct, then we will have a 1 plus 1/10. So we separated the whole part and the fractional part, and this can be written as a mixed number. That is a 1 in a bigger size and 1/10 next to that, a smaller size. That is what is the 11/10 is equivalent. Is that okay?
Yes, sir.
Okay, that is a separate line. But my first question is, have you ever thought about bringing it, how to separate them as 2 fractions? Because that was the original starting point, right? How to go about it?
Yeah.
Do you get that?
Okay.
This is what is called, in terminology wise, is called the partial fractions. Is that okay?
Yes, sir.
Partial fractions. But even in the number itself, do you get that?
Yes, sir.
Okay, partial fractions are only talked about only when it goes to the rational algebraic terms. But even with 11/10, we know the procedure, how we made this 11/10 from the 1/2 plus 3/5. So how to reverse that? So tell me, what is the first thing we need to look at? So when we did the addition, what we first achieved, because both the numbers were different families and we brought into a common family. How we did that?
We were
What
taking the LCM.
LCM of what? LCM is the procedure of doing something that is needed. But first of all, how we found that both of the numbers are different families? What told is, because the one, you see the 1
The
over
factors.
not the factors. Look carefully and then, because I explained that already when going for The first number of 1 over 2 is in which family is that? The 1 over 2 family, right?
Yeah, one by two. Yes, yes.
Yeah, it is a 1 times 1 over 2. And
Okay.
the quantity is 3
This
times
will be 3 times 1 by 5.
1 by 5. That means
Okay.
the family denominator quantity was the one deciding what family they are. Do you get that?
Yes, sir.
Okay, then we found the LCM between the denominators. Do you get that?
Yes, sir.
And that resolved into a 10. Do you get that?
Yes, sir.
So when we want to do the reverse process, this is the reverse process. Start from there, take the 10 and start making the factors for that. Is that okay?
Yes, sir.
Okay, that is how we identify what are all the families involved with that. This tells us, okay, 1 is a very common multiplication factor for any number. So we identify that there is a 1 over 2 family and there is a 1 over 5 family involved in this fraction. Do you get that?
Yes, sir.
Okay, then what we do, we just say, but we don't know how many factors quantity involved with that. This 1 and 3 is still not known, but by taking the denominator of the resultant fractional quantity, we identified what families are involved. Then we are going to write, I don't know what that is. Let's call that as a capital A divided by our 2. You're okay with that?
Okay, yes, sir.
Plus capital B over 5. Now
5,
you see
yeah.
beautifully, we know the reason why we did that. And
Yes.
completely now it looks like we know the A over 2 plus B over 5 must be 11 over 10. We have an equation, but two unknowns are
Yes.
there. Let it be. But we know that what is the understanding? This is actually we are saying A times the first family plus B times the second family. And already we have introduced the fractional amount into the family. So we are expecting both the A, this is a whole number, and this is another whole number. That is what we want. Do you get that?
Yes, sir.
Okay, so we are looking for answer in terms of, so even the property, what we are expecting should click our mind quickly. So that makes us, okay, let's start with 11 over 10 is actually equal to A over 2 plus B over 5. Get it done so that we can have the answer for A and B. What we need to do between the 2 and 5, we know we can take a common factor, LCM, that is the same principle. Is that okay?
Yes, sir.
B times 2 and this is going to be 11 over 10. So this implies our 11 over 10 is nothing but 5A over 10 plus 2B over 10. So that yield, this is actually yielding as 11 over 10 is actually equal to 5A plus 2B over 10. So multiplying both sides by 10s without imbalancing, we can actually factorize this. This tells us 5A plus 2B must be equal to 11. And we are looking for a whole number value for the A and B. Are you okay up to here?
Yes, sir.
Now, it is actually a fractional number quantity where we started, but that is why we have a single equation. So now all we need to think about it, okay, look at the 11 and try to look from the two factors, the 5 and 2, how much amount of that could be involved with it, because we have to split this 11 into two pieces. Do you get that?
Yes, sir.
Okay, so if you say that I'm going to split into 5 factors, let's say if you take 2 of them, assume let A equal to 2. Okay, first choice I'm saying. Then what will happen? This itself, the 5A itself will take 10 of them. Do you get that?
Yes.
Then that will tell 11 minus 10 will be a 1, which is lower than the 2, this 2.
Yes.
Then that means we don't have a whole number value for the B. Then this assumption is not good. Do you get that?
Yes, sir.
Then obviously we go for let A is lower value, then 5A will become a 5. That leads to 11 minus 5 is actually 6, which is greater than 2. Voila, well and good. And also it is fitting very perfectly because 6 over 2,
yes,
that's the 3 also. Do you get that? So that eventually says that the A is actually our 1 and B is actually our 3. So we can write 11 over 10 is nothing but two partial fractions of plus 3 over 5. You're okay with that?
Yes, sir.
Okay. So you catch the whole idea, right?
Yes, uncle. Yeah.
Now let's try a completely a rational fraction is the algebraic expression. Let's say 1 over 1 minus x square. Same thing, like 10 over 11 over 10. What could have produced this? And where we have to start? What is the basic reason this has simplified as a one single numerator and a addition of two terms in the denominator? Do you get that?
Yes, uncle.
Where we start? Don't take it as a procedure from the thing what we done before. Use the knowledge. What made it look like a single fraction like this, not a split of addition of or subtraction of 2 or 3 fractions?
Now we can write 1 minus x square as 1 plus x into 1 minus
The
x.
reason is the denominator is the family. Do you get that?
Yes,
We are
uncle.
trying to factorize the family, the denominator to expose what families are involved here. Do you get that? So
Okay.
factorize.
Yes, uncle.
So that is the thought process should explain our mind every time we go for it. Okay. So as you said, you know that, but tell yourself that why you are doing that. That is important. That is what I keep saying again and again. Do you get that?
Yes, uncle.
Once we have that, now we know that there is some certain amount of 1 over 1 plus family. So this is telling there is a certain amount of, call that as a over 1 plus x. And this is saying as there is some b over 1 minus x is involved with that 1 over 1 minus x squared. So when we start that, that will be 1 over 1 minus x square, which will be equal to a over 1 plus x, add with b over 1 minus x. Do you get that?
Yes.
But only difference at this point compared to the previous one is the previous one we were saying that the a and b should be a whole number because the fractional amount is completely given to the family value. Do you get that? The half and 1 over 5. Makes sense to you?
Yes, uncle.
But in this case, we are saying that we have to go one order hierarchy above. We are saying that a and b are numbers. Do you get that? Not involving the x. That is the idea. Do you get that?
Yes, uncle.
Don't expect that they have to be, we cannot force it to be a whole number. Do you get that? That is too much we are asking. Make sense to you?
Yes,
Only
uncle.
numbers. That means it is completely independent of x. That's the idea, whole idea. Is that okay?
Yes, sir.
Okay, so once that is known, then let me write straight away the step. Hope you can see that without any problem. Are you okay with this?
Yes, uncle.
I take the common denominator, least common multiple between the 1 plus x and 1 minus x, and then when you multiply it, it get 1 minus x square. Numerator is balanced exactly because of that way, and both sides I multiplied by 1 minus x square to get this equation. Are you okay with this?
Yes, sir.
And the beauty is now we are having it looks like it is a single equation with the two unknowns we are looking for. Our interest is what is A and what is B, right?
Yes, sir.
But look at here, it is beautifully, unlike the number values, if you expand it, it will be A minus AX plus B plus BX equal 1, and gather the X terms and then the constant terms separately. That means we would have our B minus A factorized with X plus A plus B. This is equal to 1. The reason why we write it in this way, the right-hand side term is dictating us how to compare the left-hand side with the right-hand side to identify what the values are A and B. Make sense to you?
Yes, sir.
Okay, once we did that, the right-hand side is simply saying there is no X is available in the whole thing. Do you get that?
Yes, sir.
This side, one is completely a number. That means this quantity, this whole quantity is meaning is 0. And this whole quantity is actually the 1. Make sense to you?
Yes, sir.
Okay, so that leads to the A is actually A plus B must be equal to 1. That leads to A and B are equal and their values are off. Is it okay?
Yes, uncle.
That will satisfy this whole thing. So half minus half is a 0, multiplied by x become a 0. A plus b is half plus half is a 1, that is equal to the right hand side. Voila, well and good. We got a fantastic thing way to 1 over 1 minus x square is nothing but a half of 1 plus x plus another half of 1 minus x.
1 minus.
That. Okay, so completely we started with totally number addition, whole number addition, and went all the way, extracted the mathematics involved with when numbers are dealt with. We went to a way. Now I give you a completely a different problem. Integrate 1 minus x square with respect to x. Do you see that?
Okay, yes, uncle.
Okay, so I might have already told you, but whenever we have this is carefully to be taken care. I will write it again, different problem. Whenever you have an integration in a rational form, that is numerator divided by denominator, both of them having the variables, because the numerator has a small part of the x, which is the integrating variable, and the denominator also got the x itself. Then always check, whenever it is a rational form, check that this is take the differentiation of the denominator. Is that okay? And check and question it whether this is exactly equal to the numerator. This is a question mark we should ask. Is that okay?
Yes, sir.
Whenever the whole integrand is going to be a numerator and a denominator form, and it is a rational form involving numerator and denominator both have the integrating variables one way or the other, then we need to check this. So in this case, the differentiation of x is what? What is the answer for this? X is
1. No, sorry. 1 second. 1 by x. Okay.
You can tell whatever it is. What is the d itself? D is just asking what is the change happening to that quantity in the bracket. So what is the change happening to the x? Dx. Why you are confusing yourself?
Okay. That's
because
it.
you are always thinking you are differentiating with respect to x. You said answer is a 1 because you are differentiated with respect, but the d is not telling us with respect to what to differentiate. Do you get that?
Okay. Yes, sir.
It's a generic implicit differentiation. That is the basic idea, right? Why we go to that teeny weeny amount, small amount of any variable, we need that. So now this is exactly equal to the numerator. Do you get that?
Yes, sir.
So that means whenever you have that condition, when you take the denominator, differentiate implicitly, and it comes exactly the numerator, the answer for this integration is the natural logarithm of this denominator itself. Is that okay? Plus an integration constant c. Make sense to you?
Yes, sir.
Okay. So parallelly, I will do a different problem to make you to feel comfortable. What is integral dx over 1 minus x? What do you do? The checking point is, first of all, what is the first checking point? It is in the rational form,
Same
and
form.
numerator and denominator got the x. Do you get that?
Yes, sir.
Then how to check it? How to check whether it fits into the particular case of natural logarithm. You understood the previous case, right? You're okay?
Yeah, yes, uncle. Yes.
So what we should do when you have in a numerator and denominator form, and both of them have the variable x, which is the integrating variable. Now what we should check?
If it belongs to the same family.
Not the same family. All we need to say is, in this case, I told you, right? Okay, take the denominator, differentiate that. And if it comes to exactly the numerator, then we are in the log as the answer. Do you get that?
Okay, got it. Yes, sir.
But don't get it as a formula. Do you get that?
Okay.
Whenever it is a rational form, because we have this very special case, okay? The very special case problem is we have that the differentiation of the ln x or the log base x, this comes to 1 over x. Do you get that?
Yes, uncle.
That is a very special case, and we know we derived this, right? Did we or not? Why the
Yes,
not
sir.
yeah. So as it is a special case, we have to be careful whenever we integrate, because the 1 over x, we know it is a integration is ln x. So that could be a hiding in any form. Do you get that?
Yes, sir.
So as long as the integration looks like a fraction, and the fraction numerator and denominator involve the variable x, then all we need to do is take the denominator, implicitly differentiate. What is the differentiation of 1 minus x?
It will be 1 minus x.
Okay, all of them are okay. If I put you d by dx of 1 minus x, what you do?
That will be minus 1.
Why it is a minus 1 here and it is not a minus 1 here? It is still the same answer, but only thing is we are not differentiated with respect to any variable. Then the x has to be differentiated also. That is what the implicit.
Oh, okay.
Eventually, what you get should be the same, because if you
Okay,
rearrange
got it.
okay, if you rearrange
Yes,
this
got it. Because
yeah.
d by dx will come. That's okay.
Don't take it as, but this is the
Okay.
starting point. Okay, this is the first learning should be. This is a
Okay.
very special case. Do you get that?
Yes, sir. Got it.
Because the students are all taught with the special case, and they are always thinking that d by dx is something like a plus symbol. And they are not even thinking that the x is actually a operand one. You see the beauty of, like, if I say 2 plus 3, addition is independent. Do you get that? This is an addition
Yes.
operation. It is not only for these 2 and 3 or something like that. But it is a quantity which needs 2 operand. So plus is, without these 2, plus cannot do anything. It doesn't make sense on its own. Do you get that?
Yes, sir.
Left hand side, right? So in mathematics, every operator will be, people say that even minus also needs that, but sometimes they call that as a unary operator -2. Minus is a thing can stand alone. But I would say that there is a 0 hiding in front of that. Still minus needs a left hand side and right hand side. You're okay with that?
Yes, sir.
Okay. So same thing, if you write even a 3, that is a +3, a 0 is hiding here. So that plus belongs to the same kind of category. Do you get that? Similarly, if you write d by dx, dy by dx, for example, this is a differential operator operated on y and another differential operator operated on x. Even the d needs one operand and another d needs another operand. Do you get that?
Yes, sir.
Okay, and the small change happened in the y is dy. That is why we write it as a simply dy. The small change happened in the x is dx. But in the case of, if you look for the small change of only a variable, you simply say that the change happened to that, variable. Is that okay? The name doesn't matter. If you ask for what is d of a, as long as they have not said that it is a constant or something, the a answer is a dA. You're okay with that?
Yes, sir.
But if you specifically ask what is the change happened to the particular variable, compare with a change happened to another variable, it could be the same variable. Do you get that?
Yes,
then
sir.
in that case, we know this is a dx on its own and this is a dx on its own. They are exactly same value. They fit 1 to 1. So they factorize to answer 1. But if I ask you what is d of x itself, it stays as a dx, end of it.
Okay.
Okay.
Yes, sir.
So the implicit differentiation is the first thing. The explicitly with respect to some variable comes later. Is that okay?
Yes, sir.
Okay, that is the same thing. Like if I give you a okay, we will see that whether if you have the trouble once again. So now we got here. So this is the point where we stopped. That we took the denominator and we differentiated implicitly and we got a minus dx.
Yes, sir.
Does this have the same functional form as the numerator or not?
Yes.
Only minus is missing. Do you get that?
Yeah. Yes, sir.
To deal with that, all we need to do is make it as a minus dx and multiply the minus another minus. That will take care of that. Is that okay?
Okay, yes, sir.
So this will make us okay, voila. Now if I differentiate 1 minus x, the answer is a minus dx. That means this part alone, integration alone, the minus is waiting outside this minus.
We log
Integration analysis ln of 1 minus x
ln of.
denominator.
Yes.
You're okay.
Yes,
It's as simple as that. With understanding, everything will make sense. And we can algebraically, the log function minus is a minus 1 multiplied with. This can be written as a ln of 1 minus x whole power minus 1. This is actually equal to ln of 1 over 1 minus x plus c. Is that okay?
yes, sir.
Okay, we can write like that. Similarly, now we come to a point, integral of dx over 1 minus x squared. What is the first thing that should click your mind?
It will be like 1 plus x into 1 minus x.
Why you are not checking that whether it belongs to the logarithm answer? This integration could be log, right?
Oh, right. Okay, yeah. So first you have to differentiate 1 minus.
Yeah. Again, you are still working like a mechanically you are working. Do you get that?
Yes, sir.
You are not using, first of all, before taking a step, because okay, I mean, we did partial fraction and everything, that is all okay, we can factorize and everything, but you should have a systematic way of why you are ending up with a partial fraction rather than, okay, even I would say that, okay, if I give you integral dx by 1 minus x, we just solved this, right? Isn't it? Yeah. Don't you think that 1 minus x can be written as a partial fraction? Is it impossible or possible? Tell me that 1 minus x can be written as a factors or not?
Yeah, they can.
Okay, tell me the factors.
Oh.
1 plus root x.
1 minus
Root x.
Yeah.
You could have done that also, right?
Yes, sir.
Whether that is really necessary or not, first the easy check has to be done systematically. That is differentiating the denominator to check whether it is in the form of the numerator. It is a better thing than dealing with all this irrational nonsense. Do you get that?
Yes, sir.
That's why we did that, and it fall into that family. Then we never thought about doing the partial fraction. Do you get that?
Yes, sir.
So same thing should be happening with the other thing also. Integral, keep it as simple as possible. Do you get that?
Okay.
We are putting effort. You are going to do the partial fraction and everything. Eventually, that is not going to help you. What is the point in doing that? Okay, so
yes, sir.
Even though we take a step, spend time on something, before that analyze and put it in a way that what can easily to be checked and do things. So just to differentiate the 1 minus x square, what is the answer for this?
The minus 2x dx.
Fantastic. That is how we have to think, and our mind should work with the implicit differentiation straightforwardly like that. Now check the form, the functional form of the answer, whether it is fitting into the numerator or it is not.
No.
Not because it is in the x dx form,
X
but
dx
is
is
simply
yeah.
a dx alone. Do you get that?
Yes,
that
sir.
why then we are thinking, can I go for some other way to deal with? But currently it is in the algebraic form. Do you get that? The denominator
yes,
is
sir.
1 over x squared. So as you said, the partial fraction, because the 1 minus x square is actually pleading to us. I could be factorized as a 1 plus x multiplied with 1 minus x. So this whole integration, integral dx over 1 minus x square can be written as half times integral dx over 1 plus x plus another half times integral dx over 1 minus x. Is it okay?
Yes.
Okay. You see, Karishma, even when I learned at your age and everything, nobody told me any background reason and everything about this implicit, explicit differentiation and what is the real integration means and everything. It was all bombarded to me and I did it correctly without learning what is the background reason for any of those. Do you get that?
Yes, sir.
But it took me time. Like now I am 51 years old. After so many years, I am having a clear idea about all this stuff. And now with that, it's not only to explain to students or other learners who want to learn, how I can use it for other purpose is immediately popping out. Do you get that?
Yes, sir.
And what to be done for anything to be achieved, I first analyze and feel it completely and get the full understanding, extract everything. then after that, the things will be very easy and we will enjoy us also. You're okay with that? So you are
Yes, sir.
exactly like me I mean, when I was at your age now. Do you get that?
Yes,
But
sir.
you got a person who could help you to think and understand, which will make you to learn in a better way. That will save lot of time and you will be much better than me when you come to my age. Do you get that? In dealing with anything.
Yes, sir.
Okay. So that is the way you need to. So don't rush it. Okay. Because exam you have no time, then you need to do it. But when you do it with the exercise or when you are learning the concept and everything, if you get the full understanding, because it is not about integration like that should be immediately split into factors and do the partial fraction and everything. The reason why that will effectively make the integration get solved, that should be the learning. You get that?
Yes, sir.
Now you see that comes to beautifully. So if I write it straight away, I hope you don't mind. This will be a first integration will be a ln of 1 plus x, and the second integration would be minus of ln of 1 minus x. You're okay with that?
Yes, sir.
You see, I don't even need to explain everything because you could see that now if you differentiate the 1 plus x, of course it is a dx. That's why we can write the ln of denominator as the first integration answer. In the second case, second integration, ln of 1 minus x is a minus dx. That is not available as a minus, but that is a constant. That means it is in the ln family, but only the minus is missing. Use a minus multiplied by minus. Use one of them as a factor available as outside and another factor will be used for the integration, become a ln 1 minus x. And next, how to simplify this expression? Is it possible to simplify this? This is an algebra
Yeah, we can write it as half can be taken
as a power.
commonly.
Then it will have two log function getting subtracted. You get that?
Subtracted, so it will be a by b.
Okay. So this will be ln square root of 1 minus x over 1 plus x. Is it okay?
Yes, sir.
Okay. So there could be a question, a function is given by a square root of 1 minus, sorry, it should be 1 plus x by 1 minus x. I was thinking correctly, but writing wrongly. I don't know why. You see, I already thought that I'm going to write the denominator 1 minus x. That made me to write the denominator as a 1 minus, numerator as a 1 minus x.
Okay.
Okay, so if you are given this, and if you are asked to find dy by dx, you should get the answer as a 1 over 1 minus x square in the simplest form. Do you get that?
Yes, sir.
Even though it looks such a, okay, I missed the ln. That also you did not, you're okay with that? Makes sense?
Yes, sir.
Okay.
Yes, yes.
Okay, you see how the partial fraction can be really helpful. Okay, in the case, we have to be very careful how to, when you need to deal with the partial fraction, unnecessarily there is no need to deal with that. Is that okay?
Yes, sir.
Okay, so the integral, let's say x dx divided by 1 minus 5 x square. What do you do?
Okay, so first we differentiate the denominator.
That is the simplest thing to handle. Do you get that? Rather
Yes.
than going for partial fraction and everything. Okay. So this will be d of 1 minus 5x squared. So the answer is
Minus 10x dx.
minus 10x dx. Fantastic. Is it in the form of the numerator or not?
Yes.
Yeah. Only thing is the numerical constant minus 10 is
Yes.
the extra factor we need. So the answer is, if I write it as a minus,
Take minus 10 outside.
yeah, minus 1 over 10 ln
Yes.
of 1 minus 5x squared. You're okay with that?
Yes, sir.
End of it. You see, in one step, we could get an answer. Is it okay?
Yes, sir.
Okay, so that should be the deal. Is that okay?
Yes, sir.
Okay, integral tan theta d theta.
Okay, so first,
Okay, that also you need to have that, we know the generic one. Whenever there is an integration of a variable which we are going to integrate with, with a constant sitting on its top, for example, x power a or something like that, we know without doing lot of process how this x power a has appeared from a function after differentiation. Because of that, we do the reverse operation as long as this belongs to this, the base level. And
Yeah,
this
x to the
constant.
power a
Okay.
plus 1 by a plus.
Increase the power by 1 and divide the whole thing with the new power. So this is what making us, whenever we are integrating, as long as belongs to this kind of algebraic polynomial expression, then we go for that. Do you get that?
Yes, uncle.
The reason we look that in that way. So like that, in the previous case, whenever it is a rational form, do the check of denominator differentiation, whether it fits into the numerator functional form. Like that. Same thing, even basic integration differentiation as that. Whenever you have integral e power some n x dx. This means as long as the base level is a natural constant. Is that okay?
Yes.
Natural constant, then this has, whether it has it or it doesn't have it or it doesn't matter. Okay, it has that variable, and whatever the factor involved with that is actually simply it doesn't matter, but in this case it is a constant. Is that okay? So, but either case, if it is a natural constant in the base level, we don't need to worry about that. This integration is going to be e powered the same answer. But only thing is, you need to do the differentiation of the whatever the argument of the natural constant with respect to the integrating variable. And we have to divide that because it is a chain rule. You're okay with that?
Yes, uncle.
Same thing. If you have integral, our sine theta, okay, I always missed a c with everything. It's all indefinite integral. Okay. Okay. So if it is a sine something like, say alpha theta, d theta. Is that okay?
Yes, uncle.
Yeah, what is the answer for this?
Sine will be, it will be minus cos. So
Cos of what?
minus cos alpha theta
Alpha theta. Then it is all, or it's still there?
divided by alpha.
Divided by d theta of alpha theta. Is that okay?
All right. Okay. Yes, uncle.
Okay, I keep it this way. This is the better way to understand. Do you get that?
Okay. Okay. Yes, uncle.
Okay. Similarly, the last one in the trigonometric function is integral of cos by db. What is the answer for this?
Oh, it will be sine by divided by y. Sorry, d by db.
D by db of by.
by.
You did it correctly, yeah. But I'm saying that implement that. Do you get that?
Yes, yes.
One extra step will make us to always remember why we need to do that, and that become natural for us. Do you get that?
Yes.
Okay, why I wrote all this generic form? Because these are all the forms we can write the integration straightforwardly. There is nothing else. Okay, there is one more also we can take it, but that also could be derived from the e power. That is integral some dx by some ax or something like that. As long as a is a constant, then we can write this as a 1 over a ln x plus c. Is that okay?
Yes.
Okay, so all these are all standard. Okay. Okay, so but the one we got is integral tan theta d theta. It is not in the standard form. Do you get that? Then we need to do something to get into any of this. Make sense to you?
Yes, sir.
Then we are good. That is what always we need to do. So now think what is the better way to deal with the tan theta function. It's not in the standard form. We need to do some kind of equivalent for the tan theta. Tan theta has many equivalent things. Do you get that? But go for the one can help us to fit into any of these. Also, I mean, I'm not giving you a problem which not to the level of a 12th standard student. Is that okay?
Yes, sir.
So you don't need to work out too difficult thing. First, you also use the what is the first definition you know about tan theta?
1 minus secant.
About that is too
Secant.
much. That is you are asking for too many other things. What is the very basic tan theta definition?
Or sine by cos.
Why that is not clicking your mind? Are you okay with that?
Yes, sir.
Now what has it become? Even though it was given as a normal one numerator alone, denominator was a 1, it automatically converted into a rational form. Do you get that?
Yes, sir.
Whenever it is in the rational form, what you do?
We have to differentiate the denominator.
Exactly. Do the differentiation of cos theta.
Oh.
What is the answer?
It'll be minus sine
Uh,
theta d theta.
Okay. Is it in the form of the numerator or not?
Yes. Oh,
Okay.
okay.
So the
Except
answer
for
is
1 minus.
straightforward.
Yeah.
It's a ln of 1 minus tan theta plus c. End of it. You're okay.
Okay. Yes, uncle.
One line answer for tan
Yeah.
theta integration. You see, the understanding led to go for this. If you force
Yes, uncle.
any other way, okay, eventually you may get an answer, but not in a more peaceful, enjoyable way like this. Do you get that?
Yes,
This
uncle.
understanding makes sense to you?
Yes, uncle.
Okay, so similarly, let's try this integral cotangent theta d theta. What do you do for this?
Yeah, this one we can write it as cos by sine.
Cos theta d theta over sine theta is
And
equal.
differentiate.
Yeah, okay. That fits or not?
Yes, it does.
Then tell me the answer straight away.
Yeah, it'll be cos theta d theta. Oh, okay. Ask me to tell the answer. Okay, 1 second. So it'll be
You differentiated the sine theta, it is exactly the numerator.
yes.
This is the answer.
It'll be log sine theta. Sorry, ln sine theta
Plus C. Is that okay?
plus c. Yes, uncle.
Okay, so let's say if you have integral cotangent some root 5 theta d theta. What do you do?
Okay, so when you differentiate that, it will be 1 second. We write it as cos.
The chain rule and everything will work. You are going to divide that by differentiation of root 5 theta with respect to theta and everything.
Yeah.
That is one way to deal with that, but better way to handle it is because mistake may happen in dealing it in one go like that. Substitution method is always better. We have a substitution method. Is that okay?
Okay.
All we need to do is ask for a single variable root 5 theta. So then we need to convert everything in this integral into a form of x. All theta should go to. So how many places theta appear? First is the place.
Yeah, and then d theta.
Substitution to 2b. So we need a d theta. What is the value for the d theta? That could be obtained by differentiating this equation completely. You are okay?
Yeah. Yes, sir.
Of x equal to root 5 theta. That is actually equal to our d of x equal to d of root 5 theta. Okay, so dx is nothing but root 5 d theta. So d theta is actually
dx by root 5.
Yeah, 1 over root 5 multiplied by dx. Is it okay?
Yes. Yes.
Why write it as a 1 over root 5? Because it will be easy to write it here. 1 over root 5.
Yeah, yes, yes.
This is the one you are looking for the denominator chain rule. Do you remember that?
Yes. Yes.
So, but you see, one step with the substitution make us confidently to do that. Is that okay?
Yes, uncle.
It will be a cotangent x dx. So this we already know that it is a root 5 and this will be ln sine x and the sine x. Okay, we can write it straight away as a root 5 theta because the final answer we are looking for is in terms of theta. Is that okay? Plus c.
Yes, uncle.
You see, with the confidence, whether we are going to do the chain rule correctly or not, this will help us. Is that okay?
Okay, yes.
Okay, so let me go ahead and try different things. Let's say if we want integral dx over square root of 1 minus x square. So all we are looking for is, again, keep it in thought process. Can we conveniently convert this into the standard form of integration? We know only 5 of them are there. Polynomial form, the e power form, the 1 over something will give us a ln form, that is natural logarithm as an integration. Sin theta goes to minus cos theta goes to sin theta. Those are all the standard forms. One way or the other, whatever the method we choose, we need to convert this into that form. Then only we will get the answer. That should be the thought process. Do you get that?
Yes, sir.
Okay. So keep your open mind. We have a
This one actually, I know a direct formula for this, but
no,
I
the
think
formula won't work because your formula kind of thing is going to kill us. We are not learning anything by using formulas.
yes,
Take that.
yeah,
Because we are not mechanical machines. Okay. So now you see, okay, it is in the rational form. Do you even try to check the differentiation of the denominator in this case or not? Will it
no,
fit?
because it won't be. It won't be.
You see that, you see even that effort, because always I was saying it is in the rational form, why you are not doing that? But this one, we know we would be
Yeah,
unnecessarily doing that. So, okay, forget about it. And also why we have to forget about it? Because the killer is square root. Do you get that?
yes, yes,
The square root is a killer. Think about how to, the square root has to disappear, first of all. How to make it disappear? The quantity inside the square root is called the operand for the square root function. Is that okay?
yes, sir.
If that become a square quantity, then the square root will be compensating with that. Do you get that?
Yes, sir.
Now, 1 is a constant. Minus is another constant because minus 1 is multiplied with the x square. Only variable with respect to what we are integrating, that is x squared. Do you get that?
Yes, sir.
Now you need to go for the better way to think is, can I do a substitution? Because even if you go for integration by parts method or something, this is going to recur again and again and again. That even this integration either it will ask you to differentiate this or integrate this because of the UV. Do you get that?
Yes, sir.
So don't even think like that. Okay, it is in a denominator rational form. With all this analysis and explanation I am giving, your mind should do this. And now
Just to
think.
substitute 1 minus x square as some,
Not if you
like t.
completely substitute 1 minus x square into another polynomial kind of algebraic one, it will be same family. Do you get that?
Oh, right.
You see, that won't help you at all. Do you get that?
Okay. Okay, yes, sir.
Because you are saying that I want to hide from somebody, then I go behind a glass window. It won't work.
Okay.
The air is transparent, that's why people are seeing us. And if you go and hide behind something, that object you hide behind should be opaque. Do you get that?
Yes, sir.
That is the kind of property you need to think. It is already in the algebraic form. If you think I am going for another algebraic substitution like 1 minus x squared to be a whole thing to be a y squared, then it will be killed by your dx in the numerator. Do you get that?
Yes, sir.
I will tell you why you are trying that. Okay, you tried something like that, right? Let's put y squared is actually given by 1 minus x squared. This could be a good try, right?
Yes, sir.
Denominator will become a y. But what will happen? You need to have a dx equivalent. So for that, you will do a implicit differentiation. What is the implicit
Yes.
differentiation of this equation? Tell me.
Y square. Okay.
Yeah. Just to do the differentiation of the y squared. Just to do the differentiation.
Okay. 2y dy by dx.
That's no dx. Don't do that. Just to do the
Okay, right. Okay, fine. Got it. Yes, uncle. 2y dy will be minus 2x dx.
Minus 2x dx. You're okay with that?
Okay, yes, sir.
Now we need the equivalent of dx. Dx is going to be, the 2 can be factorized. This is going to be negative y dy divided by x. Now we need x. So from here, x will be, that is where it is going to kill you. Do you get that?
Okay, yes, sir.
Root of 1 minus. Am I right?
Yes, sir.
So then your dx will kill you. Your substitution will look like minus square root of 1 minus y square dy. Sorry. You should put y over. Sorry about that. Y is there. X should be replaced. Is it okay?
Yes, sir.
Minus y over square root of 1 minus. So you will end up with the same form. It won't help you at all because you chosen a algebraic form. You see how we have to learn. Do you get that?
Yes, uncle.
Experience for me is telling you already it is in an algebraic form. If you go for another algebraic substitution, it is not going to help you at all because the killer is in the dx.
Yes, uncle.
Think something substitution for the x, and that should be, when you substituted here, it should become a 1 minus square of that quantity. That should simplify as a single squared quantity. X is equal to cos theta. Why you are thinking too much, I don't know.
Oh, right. Okay.
Okay. So 1 minus
The
x
sine.
squared is going to be 1 minus cos square theta, which is actually equal to sine square theta.
Sine square theta. Yes.
That will
And
give
under the
square
root, that will
root of
become
1
sine
minus
theta.
x square as simply our sine theta.
Sine theta. Yeah.
You see that, right?
Yes, sir.
And we need to have the numerator, we need the dx. So do the dx. Dx is what? Minus sine theta d theta. You're okay with that?
Yes, yes, sir.
Okay, so you see the beauty, denominator is converted into a sine theta. Numerator dx itself already produced a sine theta, which will be 1 over the other. So the substitution would be integral dx over square root of 1 minus x square simply become integral minus sine theta d theta over sine theta. Sine theta factorize. This answer is minus theta plus c. So theta is nothing but, we put x is equal to cos theta. So now because of that, we say theta is nothing but the cos inverse of our x. So the answer is minus cos inverse of x plus c. You're okay with that? Anywhere something not easy to understand here? Hello, Karishma.
Yes, uncle. Yes.
You're okay completely?
Yeah. All okay. All fine.
Okay, so you can do the other substitution, because I purposely put this substitution because I don't want you to tell me what is the formula they taught you. What is the answer for this? It's the sine inverse of x, right?
Yeah. Yes.
Okay, that is because the substitution should be sine theta. Is that okay?
Okay. Yes, sir.
Okay, that is why I purposely put the cos theta, because the sine inverse of x is exactly equal to minus cos inverse of x. That is an
Yes,
idea.
sir.
Okay, that we can prove that also. Is not a big deal. So if you do this, then we have the substitution square root of 1 minus x square will become a cos theta. Yeah, and then our dx will be cos theta
Cos.
theta. So because
Yes.
of that, integral dx over square root of 1 minus x square will completely become integral cos theta d theta over d theta, cos theta, and that will factorize. So this will be an answer theta plus c. So that will be equal to, we know that because of this, theta is nothing but sine inverse of x. So we are going to plug it in as a sine inverse of x plus c. You see, it's not a formula. Okay.
Okay, got it. Yes, sir.
It is the same reason the substitution method is not only for the integration. Let's say if you want to differentiate a function which is a sine inverse of x, what you do? You don't go for formula. We don't know this direct. We know only differentiation of sine x. So we go for, let's say some theta is actually equal to sine inverse of x. That tells us x is actually equal to sine theta.
Sine theta. Yes, yes.
Then we need to completely change this into that new differentiation, then everything will okay. So let's try it as, let's this complete thing become now as a d theta by dx. That is what we are looking for. You're okay?
Yes, uncle.
Okay, so that's it. So that means d of, we want d theta by dx, but we know this thing. So differentiate this on both sides with the theta. So dx by d theta is going to be cos theta. You're okay?
Yes, uncle.
Okay, so now we need to know cos theta. Then this to this is 1 over. So our answer is d theta by dx, which is the one we are looking for, is 1 over cos theta. Okay.
Yes, uncle.
Cos theta is nothing but square root of 1 minus sine square theta. That is square root of 1 minus x square. So that is why the answer become 1 over root of 1 minus x square. So that is why it's given as a formula. The d by dx of sine inverse of x is 1 over root of 1 minus x square. But it is a one step of substitution will get you there. Do you get that?
Yes, uncle.
Makes sense to you? This is the confidence.
Yes, uncle.
This is the way we can become better, and compared to ourselves, we will get smarter and the thought process will get better. Don't ever jump into the formula magic will make us more dummier than what we were before. Do you get that?
Okay, yes, uncle.
Okay, you may have the other tuition or something. Okay, we'll
Yes.
catch up next. Any questions?
No, uncle. No questions.
Okay, we will catch up next week. Okay.
Thank you, uncle.
Bye then. Yeah, bye.
Yeah, bye.